friends. Our today's lab is regarding EBGP and IBGP. Here we have a topology in which you can see we have two autonomous systems. One autonomous system is 10 and the second one is 20. In AS10 we have a single router R1, and in AS20 we have three routers R2, R3 and 4. Uh, we will establish the EBGP connectivity between R1, R2 and R1, R4. As you know that EBGP is um, mm, the, the BGP connectivity between two different autonomous systems, and IBGP connectivity will be within the same autonomous system, which is AS20. So let's start our configuration here. Here we will start the configuration from R1. Enable config terminal, hostname R1, interface serial 2/0, no shutdown, IP address would be 1.1.1.1, and subnet mask would be 255.255.0.0.0. Second interface, okay, we will configure the second interface later. Now we will configure loopback address on this router as well. Interface loopback 0, shutdown IP address would be 192.168.1.1.255.255.255.255. Loopback interface 1. Loopback interface 2. So we have configured three loopback interfaces on R1. Now we will configure R2. Config terminal, hostname R2, interface serial 2/0, no shutdown, IP address would be 1.1.1.2.255.0.0.0. Exit interface serial 2/1, no shutdown, IP address would be 2.1.1.1.255.0.0.0. Here we would as we are going to configure IBGP, so we will use OSPF as an IGP protocol here. Router OSPF1 network 192.1.6, sorry, 2.1.2.0.0.0.255.255.255 area 0. Similarly, we will configure R3. enable config terminal, host name R3, interface serial 2/1, no shutdown, IP address would be 2.1.1.2.255.0.0.0, interface serial 2/0, no shutdown, IP address would be 3.1.1.1.255.0.0, router OSPF1 network would be 2.0.0.0.0.255 area 0 network 3.0.0.0.255 area 0 and R4 would be config terminal, host name R4, interface serial 2/0, no shutdown, IP address would be 3.1.1.2.255.0.0.0, interface serial 2/1, IP address would be 4.1.1.1.255.0.0, router OSPF1 network would be 3.0.0.0.255.255.255 area 0. Now we will configure the BGP on R1, EBGP activity on R1 in fact. Exit router BGP 10. 10 is the autonomous system number. Now neighbor is 1.1.1.2, remote AS is 20. Remote AS is 20 and the neighbor is 1.1.1.2, the IP address of this interface. Now we will configure the same EBGP connectivity on R2. Router BGP 20, neighbor is 1.1.1.1, remote AS is 10. There you can see that the neighborship has been established between R1 and R2. Right now we are configuring the EBGP connectivity on directly connected interfaces. Usually in practice you will see that EBGP connectivity mostly configured between the two directly connected interfaces, but you can also configure the EBGP connectivity between in two loopback addresses as well. But right now we are configuring the EBGP connectivity between two directly connected interfaces. And the second neighbor would be 2.1.1.2, remote AS is 20. This is the IBGP connectivity. R2 has an EBGP connectivity between with R1 and IBGP connectivity with R3. Now we will configure R3. Router BGP 20, neighbor is 2.1.1.1, remote AS is 20, neighbor is 3.1.1.2, remote AS is 20. router BGP 20 neighbor is 3.1.1.1 remote AS is 20. Connectivity has been established. In fact, the neighborship has been established between R3 and R4 as well as R3 and R2. Now we will advertise the network prefixes on R1 via network command. Network is 192.168.1.255.255.255.255. Show IP BGP. Here you can see network prefixes have been advertised here. The next hop is 0.0.0.0, which means that these network prefixes are being advertised on the same router, and wait also indicates that these are the self-advertised network prefixes. If we see on R2 exit IP BGP, show IP BGP. Here next hop is 1.1.1.1, which is the IP address of R1's this interface 0.2/0. Here you can see weight is 0, means these network prefixes are not self-advertised. And on 3, let's check whether R3 received same network prefixes or not. So IP BGP. R3 has received the same network prefixes, but these network prefixes, here you can see the next hop value is also incorrect, as well as these network prefixes are not the valid best. So this is because R2 is receiving these network prefixes via EBGP connectivity with R1. So R1 R2 will not update the next hop information for the next router. So we have to configure a command on R2 here in order to make it to change the value of next hop on R3. Config terminal router BGP 20 neighbor is 2.1.1.2 and sorry, next hop self. Now if we see on R3, clear IP BGP out. Now you can see the value of next hop has been changed, as well as the next hop network is valid best now. This greater than sign and static shows that this is the valid best path right now. Now on R4, exit show IPPGP. Here we have nothing to show. Why the mm, network prefixes are not being shown on R4? This is because as being the IBGP connectivity between R3 and R4, these network prefixes are not being advertised till R4. So we have to make the route reflector on R3 in order to make them advertised on R4 on on R3 config terminal router BGP 20 neighbor first route reflector client. Similarly, on now we will be able to see these network fixes on R4 as well. Here you can see, but the next hop value is still incorrect here, as R4 is receiving these network prefixes from R3 from this interface R3.1.1.1. So we have to configure route map on R4 here. Config terminal route map test 1 permit 15 set IP next hop value as 3.1.1.1. Enter and exit router BGP 20 neighbor 3.1.1.1 route map test 1 in clear IPBGP static in show IPBGP. Here you can see that the next hop value has been changed for the network prefix. And this is how you can configure the EBGP and IBGP connectivity between the routers of different autonomous systems. Moreover, you also learned how you can configure the route reflector client in order to advertise the network prefixes if you are not um, able to receive the network prefixes on the routers connected uh, from the uh, routers connected away from the edge routers. Here, as you see, saw that R2 is being able to receive the network prefixes from R1, and R3 was able to receive the network prefixes from R2, but it was not able to update the next hop value. So we configured the next hop self command on R2. Later we saw that R4 was not able to receive the network prefixes from R3. So then we have to configure the route reflector on R3, but that command updated the network prefixes on R4, but it didn't update the next hop value on R4. So we have to configure the route map on R4. So guys, if you have any query regarding this lab, please don't feel free to ask questions in comments. Don't forget to like this video. Hope you will definitely be able to learn something from this video. Thank you.